Hi, dear friends. It's cool to see you. I'm sorry, but I have to start pessimistic today. My pessimistic message is that I'm afraid we've been misusing the web for quite a long time. The thing is that the web and the HTTP was not designed in the way we are using it. It's not meant to do that work that we force it to do. And although it sounds kind of ridiculous, but we are web developers and we should have some feelings and respect to the web and not treat it that way. You might think, this guy is crazy. But who of you has seen videos of Boston Dynamic robots? Do you remember that part? We do this to the web. Let's not do it. So what I mean by saying the web abuse, the HTTP protocol, it's created around the request and response cycle. That's it. There is no progress reporting. There is no multiple responses per request. There is just a stateless request-response cycle out of the box that we get there. So this is the very basic idea of the HTTP as it was designed at the beginning. There is a single web page. We do one request. We ask for that page. We get a response. Perfect. Everything works. Well, with some time, the web became smarter. So we needed the application server. And it also became more beautiful. So we needed styles, images, stuff like that. Obviously, it resulted in more requests, which is still okay. Like, you see there are a few additional requests. That's still fine. And then at some point, we invented icons. Everyone loves icons and smileys, of course, but there are dozens of them. And then we started to notice that there is a little problem with too many requests, maybe. And someone just wanted the problem to be solved, you know, the standard management approach. Like, we have too many requests, we have too many images, merge them together. Let's have just one big sprite of images or the icon font. And we use hacks like this with using the frame and moving the background offsets to show the correct icon in front, just to save HTTP requests. Well, this is the start of web abuse to me. Like, when I saw that, like, it's not the very clean solution. Although WebSockets is obviously nothing to do with this, but it is a part of the story. So to figure out how it actually should work in the perfect world, let's think for a moment of the normal human communication. Like, how do we people talk? How do we people communicate and solve our problems? So in a glance, it's a dialogue. It's a group of two or more people that have a friendly dialogue. Everyone is expressing their opinion. We're exchanging our thoughts. Of course, I meant the healthy communication, not the president debates or something like that. It doesn't really work like that. Anyway, that's human communication, how it works. Well, on the web, it's different. On the web, we are dictators. This in the middle is the client, the browser, or us. And on the sides, there are tabs of the browser. We say, hey, BBC, I want the weather forecast of Florence. 22 degrees. Yes, sir. And so on. Well, it kind of worked in that initial scenario of the web, but it's not very elegant, I have to say. And then Ajax came to the rescue. Ajax is cool, but remember that Ajax is just solving the client-side problem of this thing. So for client, it's asynchronous, but for the backend, it's a totally same thing. For the backend, it's totally no difference are you making the Ajax request or the normal request, technically. So when we are solving the problem of the client, and actually indirectly, we are also lowering the overhead because if we have Ajax, we do not need to request images, style sheets, and so on every time. But for the backend, it's still essentially the same thing. And then it gets crazy with Ajax when we want to fetch some periodic updates from the backend. So you see that this does not scale that good anymore. And at this point, we noticed that, no, it just cannot work like that. We want real-time updates, but we do not let our servers speak. And this is the core of this problem over here. Obviously, this won't scale, and it's not elegant at all. So coming back to our army parallel that I already mentioned, it's basically screaming on the server like, BBC, any updates? No. And now. Kind of that. So long polling is here to rescue us. Long polling was a smart idea that is already going in the right direction, but as I mentioned, it's still using the HTTP protocol that was not designed to solve this problem. Well, with long polling, we make a request to the backend. We keep the connection open, say keep alive. And we wait for the data to come from the backends, and if we need, we just reconnect and do the same thing again. All over HTTP, just as we did with normal request response cycle, but now we just wait. So this is, of course, like kind of more elegant, because now it's sort of asynchronous, the way that we request the data and the way that the backend can decide when is the data available and send it to us. Nevertheless, we still have all of the overhead of the HTTP and the headers and the connection establishing and so on. And we can get into the trap of the proxy servers, of the caching servers, of anything that is staying in front that would buffer our response, which is basically what the web was designed for, to cache and to buffer. But we're using it just in a kind of wrong way here. On another hand, well, I don't have any army example for this one, but I have a romantic example, because this is now way more romantic than that, because you are asking something, and then there is just silence. You are basically just looking into someone's eyes and waiting for the reply, for some hypertext. Well, the problem here also that I am not certain I'm on that kind of relationship level with websites, so. Yeah, let's do it right. Let's not use any hacks, because nowadays we have technologies like WebSockets that can solve these problems natively. So let's not abuse the web, and have a little example in Python of multiple ways that we can fix it. WebSockets. So this is finally the only abuse-free way to establish the duplex communication on the web that I see as of today. There are more than that, but this is like a pure one. And the thing I like is that you do not need much of the dependencies to do it. The browser support is totally perfect. Like, you can use it anywhere now. You don't have an excuse. You do not need polyfills. And you can use a plain native JavaScript. You do not need jQuery or other frameworks on top, or even Socket.io and stuff. You can just use pure JavaScript and write it very easy. You don't need to learn even JavaScript. It's very self-explanatory. I'll show you everything in a minute. So the WebSocket is a protocol. It's not HTTP, but it was designed to be supported and used together with HTTP. It's a totally different protocol. It's basically just an extension of the socket idea in the web, using HTTP ports in order to provide us maximum compatibility. So it's using ports 80 and the SSL port 443 for the secured connections, but the protocol is totally different. It was designed to minimize the overhead of establishing connection of the data packages that we need to send back and forth just to keep the connection alive. This is not any longer required here on WebSockets. And finally, yes, we still support the HTTP proxies and firewalls because the ports are standard. And we are just using the HTTP upgrade header in order to jump like from HTTP to the WebSocket protocol. Well, I love the upgrade header because it sounds cool, is it? Like, we upgrade our client. We'd probably even charge more for that. You've just been upgraded. Anyway, this is how the communication looks. As I already said, first we do the HTTP upgrade header to say that we do support WebSockets, and then the web server also replies like, yeah, I also do support WebSockets. Then we finally establish the bidirectional connection where we can send messages back and forth over one distant connection. It should not break, and we do not need to care about timeouts and reconnecting. We just do it once and it works. And then finally, when we're done, one party is closing the connection. That's it. So in contrast with Ajax or long polling, where the server has no pure method of publishing the messages. In this example of WebSockets, every party is kind of the same. Every party is allowed to send data back and forth, also simultaneously, because it's a duplex connection. So you won't notice it. As I promised you, let's have an example of the client code, because it's a really simple one. Unfortunately, I do not have a pointer, but hopefully I can use my mouse. No, I can't. Anyway, yeah, so this is the really, really minimal page that is already enough to benefit from the WebSockets. As you see, there is no third-party libraries involved here. I just have the head and the script in the head, and I open the new WebSocket with localhost 888 and the URL of the WebSocket, and I have 3 callbacks defined below. On open, I want to say the Italy word as a message over the WebSocket. I have the on-error callback, which is doing nothing. Well, that's a very bad example. Don't do it. And I have the onMessage callback that says basically just what to do when the message comes. So writing even a simplistic chat application is super easy. You just create the div where you want to append the messages, and in onMessage callback you just do element.append whatever came into the chat. So it's really easy, and there is no excuse of not using it today because it's supported everywhere. But obviously, it's also a problem that when we have a hammer, you know, everything looks like a nail. So it makes no sense to use. We did it with HTTP, right? So we had HTTP, it was our hammer. Any problem? Okay, we do it with HTTP. Now we have WebSockets. Please do not switch completely on WebSockets. It makes no sense in many scenarios. I'll just mention in a minute, what are the good cases for WebSockets? It's obviously anything where you have multiple users communicating with a server or with each other. It's any kind of collaboration, software, chats, video chats, live updates from anywhere, the location applications where you need to track the data and display it in the real time. So basically the buzzwords are collaboration and real time. If you have these two in your task description, it's worth a look. But then there are also the bad cases. Remember that the HTTP was designed to be heavily cached, idempotent as well, and you're losing it with WebSockets. You don't have it anymore. So if you have, let's say, a million of connections going to fetch one news entry that is already published that could be potentially cached and served via normal HTTP response, with WebSockets you will have to really individually send it to everyone because it's uncacheable. That's one thing. Then there comes the error handling. In the HTTP, we have standard codes that are quite useful. Like even if you do totally any error handling at all on your new shiny website, and the user goes to 404 page, you will still display something. The browser will say, hey, this page doesn't exist. You'll think, probably I just made a typo in the URL. In WebSockets, we don't have it. All of the error handling is totally on your side. You need to embed it in the message itself that you send. You need to come up with your own status codes or any other way that you want to indicate what is the problem. If your data that you sent has some kind of the mistake or the user is not authenticated or whatever, you need to do it explicitly by yourself. So you're missing out a lot of the things that are already there in HTTP. Then, our tools. Obviously, we're going to use Python today. I want to show you just a really, really brief introduction to encourage you to use WebSockets already in your next projects, if you, of course, are not doing this yet. Because in Python, we have super simple tools to accomplish it. And even though for years, this was like a privilege of the Node community, if it's async, WebSockets, whatever, it's Node.js. Now you don't have to learn JavaScript. That little piece of the HTML plus JavaScript is basically everything you need to get started. And then you can use Python to do the rest, and it's like super simple. First, Twisted, but don't get scared. I'm not going to show an example of Twisted. Only if you have a lot of free time. That will be a workshop, not a talk anymore. So I just wanted to mention that Twisted has everything. It has every protocol you can imagine. Every networking problem that you want to solve is probably already solved with Twisted. So whenever you have this issue, take a look at Twisted. It's a callback-based framework, so the code is kind of like this. Well, if you love JavaScript, you will love Twisted too, because it's kind of a similar concept. I want to show you more simplistic approaches, and the first of which will be the Tornado. Who is using Tornado already? Cool. Anyway, I think it's worth a note. Tornado. So Tornado is quite a mature framework, I'd say. Tornado is like 10 years around already, and it's there since Python 2.5, I think. So the backward compatibility is crazy. You don't have it with async.io. So even your old projects can be already ported at Tornado, and you can use WebSockets with kind of async await-ish yield method already since 2.6 of the Python, even though you shouldn't use Python 2, but I'm just telling you that you can. Let's quickly go over this code. So this is actually everything you need to run the WebSockets and the web server. It's not just like one file from the project. It's the whole project. So you're just basically importing the stuff. You're defining the handler as a class. Here we have the check origin, which is just returning true. It's, of course, dump, but it's kind of a way that Tornado lets you to implement your own security protection against your website vulnerability, that you can check the origin, and if you trust it, you return true. If not, you return false. I just return true for the example's sake. Then the callback of opening the connection, def open, is, as you guess, what to do when the connection is established. On message, obviously, what to do when the message came in. And what we do here is we say hello, comma, and the argument, the message that we received from the browser. In this case, I'm sending Italy, so it should be hello, Italy. Should have wrote ciao, Italy, nevertheless. All right, on close is what to do when the session is closed, so pretty clear. Then just for you to know the basics of Tornado, like this part over here, is everything you need to define an application. And you do not need any external web servers for this to run. This is already a web server. It's quite a reliable one. I mean that you can put Nginx in front, but you do not have to, because with Nginx you'll have to configure the WebSockets to be let through and not buffered. This is enough already to use in production. I mean, nothing will break. Unlike the dev server of Django or other frameworks, this can be used in production already. So you define the application as tornado.web.application. You define the URL similar to the Django URLs. You use regular expressions for that. Then you say the port on which you listen, and you start the IO loop. Well, the IO loop works really similar to the async IO. In fact, it was earlier than async IO, but the idea is totally the same. We have the IO loop that is basically just an abstraction over the epoll or KQ of the operating system. It waits for events to happen, and it registers what action to do when this event occurred. Like, say the data is available on this socket, on WebSocket, for example, then do this. The database replied, do that. So it's a very fancy and very easy to use asynchronous framework that I definitely recommend for beginners. It's easy, it's super backwards compatible, there is tons of documentation on it, and as well as conference talks. And it's, I think, the easiest way to jump into the WebSocket world. Then there is Django. Well, Django, you probably know, is a huge framework. Like, it can solve multiple issues out of the box. And I cannot show you just one file that will be the whole Django project. I did my best, but I couldn't. Like, you need the project structure in Django. You need the URLs, you need the handlers, you need the settings. I found one example that is kind of putting it all in one file, but it was ugly. So I'll just show you the views part. It's not called like that for WebSockets, but anyway, this is, again, quite a simple example. It's just a handler, a consumer of a WebSocket messages that also has the same callbacks on connect and on disconnect, and finally on the receive, what to do when the data comes in. But again, this is one file out of probably 5 or 8 files. I won't lie to you that it's that easy. I mean, it's easy if you follow the tutorial, but you need to set up the Django project correctly. In the best case, you need a message queue. They recommend Redis. Then you cannot use this web server in production, obviously. You need a Daphne server that the author of the Django channels wrote himself for this. Then the protocol itself, since Django is a synchronous framework and WebSockets is an asynchronous protocol, it cannot be really integrated in the Django without changing anything. So obviously it's kind of an incompatible change that we do by introducing WebSockets in Django. And to accomplish that, the kind of a new protocol was designed by Django channels, kind of like WSGI, but the asynchronous ASGI interface that the web server has to support. And so in order to run WebSockets on Django, we're kind of wrapping Django app into ASGI app. It's not very native, I have to say. It will work, but it's already a bit more overhead. So if you have a Django project that you want to introduce WebSockets into, that's the way to go. If you have a new project, I would not encourage you to do that because it doesn't seem so seamless to me anymore. And the third option that I want to show you today is WebSockets. So it was a package that is just called WebSockets, and I couldn't skip it because it is so simple. It's even simpler than Tornado. This is how the whole code looks like. You basically just define one handler, what to do when the message comes. You open the WebSockets web server, you start it in the line 10, and it's using a sync.io event loop in order to run this whole thing. So this example works well if you do not need any web framework. You just want to send the messages over the network or consume messages over the network. This little minimalistic library will do because it doesn't have no templating engine, no session management, nothing like that. It's really minimal and fast. So now, to show you that it actually does work, I'm going to just show you a little demo. this is just a little page. Yeah, it's not doing much of an action, but I wanted to show you that this is exactly the code that I showed you previously on the slides and screenshots. You've already seen that. It's sending over the WebSockets Italy, and when the message comes in, it creates a new text node out of it and appends it to the body. So first we saw here sending a WebSocket message, and this is what it received from the backend and appended it to the body. And this example runs on all three of the backends that just showed you on Tornado, on Django channels, and on the WebSockets, using the code that you've just seen here right now. So a couple more words about the difference. Like, you have basically two main solutions for running an asynchronous event loop in Python. That's async.io, and that's a Tornado event loop. Then there is twisted one, but it's not in today's talk. So when you have to choose which tool you use, obviously async.io is like future-proof. It's something that is going to grow. It already grows. We already have the AU HTTP mini framework that lets us to serve a website using just async.io stack. But then there is also Tornado, and please don't forget about that. The advantage of Tornado is that it's fully compatible with async.io. You can convert the futures and coroutines that are written for async.io into Tornado, and you can also convert it backwards. And that is quite a cool feature. And again, if you need backward compatibility, like Python below version 3, that's basically only Tornado twisted that you can use. If you want to introduce, let's say, WebSockets into your old projects. Then, apart from that, as I said, there is twisted, but that's a really low-level framework. Only do it, please, if you are implementing some low-level application where you do not need any web features at all. Back to the presentation. Yeah. So finally, we can have a dialogue with our backends, like big and serious people. And if you are still concerned about the web abuse, there is a Stop Robot Abuse petition on the internet. Obviously, it's a joke, but when I was preparing a talk, I thought I have to include it, especially because of the comments like this. People are really emotional about this. And while obviously robots look like more human-like, but we are web developers. We shouldn't do nasty things to the web. So please use WebSockets and do not do polling every 10 seconds for updates with Ajax and jQuery on your website. And now, if you want to know more about the web, I'm just mentioning that there is a conference in Munich happening in 2 months just about web and Python. So you can just mark it down if you're interested. It's called PyCon Web. And I say thank you on this. Let's go for questions.
OK, thank you. Any question? OK.
Thank you. Great talk. If you wanted to, push something to the browser, for instance, writing something on the keyboard and then press enter and then push it to the browser, how would you do that?
Writing where?
Sending on the socket, on the WebSocket.
All right. So let's
from one of the the frameworks.
All right. So let's imagine that you are sitting with a terminal and you want to type something, and there is a client connected to your web server, and you want it to be displayed. Yeah.
Well, it doesn't have to be a web server. Just you have a WebSocket connection. I'm just wondering, how you get, input the other way into the server.
Yeah. Yeah. So of course, yes. I got it. So yes, you mean that here in this example, we still have been first sending something to the backend, and only then we got the response. It's true. It looks quite similar to what we do with synchronous HTTP, but it was just an example, obviously. So as I said, that since we are relying on the asynchronous event loop, we can, for example, subscribe to some news channel. And then when the backend sees, when the event loop of the backend sees that there is, for example, the new information available in the Redis queue on the backend, the event loop will take that message, find the responsible coroutine or a function, if you say that that is waiting for the news on that channel, and it will send it as an argument to that function. And inside of that function, you do the WebSocket.write and that data. So this way, it will be initialized by the backend side, the communication. But in order to establish this channel, of course, the client has to ask first anyway, just to make sure that the client supports it, to exchange the handshake, and to establish connection. Client does it first, and then the connection stays alive. Regarding this topic that you mentioned, it's actually, I skipped this part, but it's quite a big one because you need a routing on your backend to know which client is waiting for what. And then if you have multiple servers, which you most likely do, you also need to keep this somehow synchronized. Like if one client is subscribed to one server, it's a chat, and another client is sending him a message to another server. They need somehow to communicate. So obviously it's more complex than that in this example. But you just use standard design patterns from computer science. Basically, it's a publish-subscribe pattern that you just use a bit more intense. And the WebSockets is simply a transport that you're using to deliver messages without much of an overhead. And delivering messages, socket.write. That's it.
Thank you.
Okay. Other question? No question? Okay.
Thank you. Regarding the example you showed in Tornado,
Yep.
not the example, but Tornado way of doing WebSockets. Myself, I use IFTP, and I was wondering, there is already a pre-implemented way to do a broadcast messages, or how do you keep where do you keep the reference to several WebSockets, like you said in chat?
Yeah.
I was curious.
All right. Yeah. So the question is, where and how do we keep the exact routing and mapping from the subscribers to the publishers, right? So yes, you're right. So in Tornado, you do not have it out of the box. So you need to build it basically yourself. It's a bad example. It's a bad case if you want to build some complicated broadcasting software that will send a message to a particular group of users that belong to a particular group. It will be more difficult because you'll have to implement it yourself. In Django channels, first of all, you already have the user sessions and user groups integrated in the framework. So when your new message comes in to the handler, you already know who is the user, to which group this user belongs, so it's much easier to implement with Django. And then in Django channels, you already have the routing included. So it's similar to the normal routing that you have in Django. And it basically does this part for you, which you do not have in Tornado, unfortunately. On another hand, when I was preparing like a minimal case of WebSockets for my project, I found out that it's not always the case that you need to do this complex broadcasting. What usually happens is like probably 80% of the cases is some news are coming into the backend and you're just showing it to everyone. So for this case, you don't need a routing overhead. For this case, you can use Tornado. If you need more, you write it yourself or use Django channels.
One of the things that you mentioned, we should take care, it's about the bad things, like it was idempotent. What does it mean exactly? If you, for example, send twice a message, it makes some bad effects or something?
Well, obviously, yeah. So it's not going to do theoretically anything bad because it's just like sending the post requests twice. You can probably save some data twice. The thing is that in general, in the HTTP as a protocol, when you do GET requests, you can cache them. You can do them as much as you want. And when you load the data from, first, in WebSockets, there is no GET post. There is just sending a message. So in HTTP, you have safe methods that you can repeat multiple times. Let's say you are on the bad network, and you are sending some requests to the backend. So you want to load the news. And you do it once, twice, 3 times, because the browser knows that it's a GET request, it's meant to be safe, it can repeat it. Also, the backend knows that. With WebSockets, you don't have it. You do a WebSocket request and nobody knows. You can do it once or twice, or will it affect? Is it just fetching the information, like asking for the information, or is it actually publishing the information? Because the WebSocket protocol abstraction knows nothing about the content of the message. Is it a request for something? Is it publishing something? There is no difference. So it's, by definition, not idempotent like HTTP, even though in some cases when just receiving the messages it is, but by default it's not, and that's what I meant.
There is a time for last question.
In the open handler there, in the method, there is something that I can read to understand which is the client that opened the channel, or I have to, or I don't know nothing, and I have to wait the first message with some token and something to store somewhere, and then identify the client when I have to write something.
You mean how do you identify who requested it? Well, yes, the first call is a HTTP call, right? They do the handshake and the upgrade. So as any other HTTP request, it will have cookies in the session, out of which you can see what is who is the user. In this example, you will not get it. So you can catch it when the user is just establishing the connection at the beginning, because this is already, this on message is already the WebSocket communication. It's not the HTTP communication. And in general, Tornado does not have user session management out of the box. So you do have access to cookies, and there are many add-ons that let you do that. But out of the box, you don't have it, because it's quite a minimal thing. In Django, you do have it. And you always have an access to the, so not here, you go to Django channels. Yeah. So inside of the consumer class, you always have access to the user directly. It's just self.user, and you have the user. So it's much easier over there. You don't have to write anything yourself. It's basically just like any other Django request handler, where you have the class attributes that say, or request attributes that can identify the session variables, the user group. It works the same way on WebSockets and Django channel too, but in Tornado it doesn't.
Okay, thank you so much.
Thank you very much for listening.